Thanks everyone for sticking around for the last time segment of this conference. This is my first time. I think this has been an amazing conference, lots of interesting talks. And since this is the last segment, I promise there will be no math in this talk and no cat pictures. Even though I have a cat, but well, I can't, like there's so many already. So I have to skip that. A few words about me. I'm an engineer at observability team in Uber NYC. This is a picture of me. This is actually an interesting picture because this is all of New York office about a year ago, including engineers and ops. And we are facing the river, so there are no buildings in front of us. So you can guess how that picture was taken. So I'm working on the distributed tracing team specifically. We've built an open tracing and open source tracing system called Jaeger. You can check it out on GitHub, and I'll show it quickly. I also was one of the co-founders of the open tracing project/standard that has been mentioned a few times. And before Uber, I worked for way many years in the banking industry, more than any engineer should really. And like the idea of monitoring there was a trader calling you and yelling that he can't book the trades anymore. And also I have an alternative talk for this, alternative title for this talk, like would you like some tracing with your monitoring? And really what I'm going to talk about is what it actually takes to roll out a tracing at a large organization, or even not necessarily a large organization. Before we do that, just like a quick recap for people who may not be like deeply familiar with tracing is why we're even doing distributed tracing, right? So first and foremost, distributed tracing is it's a monitoring tool for distributed transaction monitoring. And what we mean by that is it means like we observe how a transaction, a given request travels through the whole architecture, through all the microservices in your system, and we can measure things, we can collect logs and tags about that information, and most importantly, we collect like causality of the request. So it's very rich semantic data that none of the other monitoring system can actually collect. So logging can, but logging is later on hard to correlate. So with tracing, you get very strong correlations between what happens after what. Also, tracing, as we've seen from earlier talks, like from Ben's talk especially, is a very strong tool to use when you want to do some performance or latency optimization, as well as root cause analysis. And one thing that hasn't been mentioned much in this conference, at least this time, is that tracing is also a very strong source of data for service dependency analysis, meaning that if you have a large architecture, like at Uber, we have actually several thousand services. So no one engineer at Uber knows how this whole system works, right? It's just impossible to keep it in your head. And then tracing can actually take a look at all the data that's flowing out through that architecture and say, well, this is how it works. You can actually observe it empirically, even though you may think that certain things are communicating in a certain way. Well, tracing actually tells you how they're communicating, right? And finally, tracing provides this feature called baggage propagation, specifically the open tracing interface gives you that. And it's not specifically a tracing feature, it's actually a foundation for tracing. I'll talk about it later a bit. And also, like a quick plug for Jaeger. So we've developed it at Uber, but we've open sourced it recently. It's a tracing system. It's similar to Zipkin and Dapper. But it's built with open tracing standard inside. So like all instrumentation libraries support open tracing, and the internal data model is also open tracing compatible, so we can collect all the rich data provided by the API. It's an active development. We have 5 people on my team, and there is also a team in Red Hat who is actively contributing to Jaeger currently, plus I'm hoping some other people will. So if you want to participate in the development, PRs are welcome, and it's a very active project. And if you already have Zipkin installation in your system, that actually can work with Zipkin because it can interoperate on both wire and on the span collection layers. So now that I've talked about, let me give you like a very quick demo of what Jaeger is, and this is really not just to pitch Jaeger, but more to illustrate these features of the tracing that I mentioned before. So we have, if you go to Jaeger GitHub page, there's a demo application that we call Hot Rod, which is like a ride-on-demand service. So what you can do here is that you have some customers, you can click on one, and there's a kind of request goes to the backend, and you get a car in a few minutes. Very similar to Donut Salon, right, that we've seen yesterday. So one of the things that I mentioned is the service dependency discovery that tracing can do, right? So here's the, it doesn't show well. Let me see. So like this. So this is a diagram that was collected by the tracing system completely automatically, right? You don't have to tell it what services exist in the system, how often they communicate, what kind of requests went through. It's all automatic, and this is actually the most simplistic way that you can get this information from tracing. In fact, the tracing data is so rich that you can expand this into a lot larger graph, even with this number of services, but you can do it at the endpoint level. You can analyze different workflows. Let's say the front-end service here really has only one endpoint in this demo, but if you had different endpoints, then you can visualize completely different graphs with all the statistics, like how many requests were going through each edge of this graph. So this is very powerful data, which really isn't available in any other monitoring tool. That's why we're doing tracing, really. Another thing is, so if I search for traces for this service front end, so this is one of the traces that I would get from executing this request. So some of the other features that you already seen that Ben mentions, like if you want to analyze where my latency is coming from, so just like one glance at this trace, we apparently see a lot of like things that are wrong here. Like this is a MySQL request. Can you see that? It's a bit small. Maybe if I can. So MySQL request took 300 milliseconds. That's not normal, right? Well, this is a demo, but nonetheless, this is very, like, we're just looking at the trace and we see what's going on. Another thing here is that a request to driver service took another almost like 300 milliseconds, but we have a staircase pattern. So that's obviously like something bad going on in the service. Like it shouldn't be colon ready sequentially. It's probably can parallelize this thing. And finally, in the last stage, here there's some parallelism going on, but it's 3 at a time. So some thread pool probably limited by the number of executors that you can. So again, very quick look at these things can tell you a lot about what the system is doing, right? And also you can understand like how the services are communicating to each other. And if you want, you can actually drill down and say, okay, well, this is what the SQL request that was executing, right? If you want logs, well, let's drill down to this one. Look at this. It has like very detailed logs about the whole execution. And those logs are not just like you collected a whole bunch of entries, events from all of your instances that potentially this every service runs in its own host, right? In Elk or in Elasticsearch or any log aggregation system, if you jump them together, you're never going to get this kind of picture, because here, these are the logs that happens only by this service within that time frame, right? If you want some other service like MySQL, then okay, well, it will have its own logs. And so you get logs in the context of the things. Remember the context, the pizza pictures? That's what tracing gives you. It's not just like, oh, this is my time sequence of logs that happened. And obviously, if these things are concurrent, then looking at your log like standard output is going to be completely useless, because you're going to get like hundreds of requests simultaneously. So it's I will stop here because, like I said, it's a very quick demo. I don't want to spend too much time on it. So let me switch back. Separate display and this. Okay. So now we've seen that. Who thinks that tracing is awesome, right? Oh, pretty much everyone. Cool. Now, so what do you think, how widespread tracing actually is? There was a poll recently on Twitter that Open Tracing Twitter account ran, and the results of this poll are kind of interesting. So like 42% said yes, that they have fully functional tracing solution in their organization. And another one I find interesting is the 14% was distributed tracing, right? So what do you think about these results? Well, to be fair, that poll was systematically challenged, right? Because it ran on an open tracing channel. So, like, of course, people who are following open tracing, they will know that, like, what the tracing is. But the 14% is still kind of interesting, right? So, anyway, so If tracing is so awesome, then why doesn't everyone doing that? So like, actually, let's have a show of hands, like here. So we actually have like like 5 times more people than that poll sample, right? So how many people have tracing in their systems? If I can count, maybe 10–15%. Well, that's what I would expect, right? So definitely not widespread, not 42. So why? And the simple answer, to me at least, is that because tracing instrumentation is too hard. It's expensive, and as Aditya said on Monday, it's boring. We can argue about the boring part, but it's definitely, actually all these 3 adjectives refer to the same thing, to the fact that you need to spend time to instrument your systems, your frameworks, in order to get high quality tracing data. And well, you could say, well, you could have to do the same thing for logging and metrics, right? But not quite. So logging and metrics are actually the old school monitoring tools. People understand them well, and they actually don't require as much work to instrument as tracing does, and I'll show you why in a second. Whereas tracing it's both a new paradigm for many people. A lot of developers don't even know what tracing is, distributed tracing, and it's actually harder to instrument your system to get the tracing correctly. And so why is that? And the reason is because tracing fundamentally relies on a thing called distributed context propagation. And what we mean by that is that, let's say you have a request which goes through your architecture like this. This is like the call graph of executing one single request from the edge service, right? So context propagation means that we associate a certain metadata with that request, with that distributed transaction, and we pass that metadata around through all the RPC calls that are happening. This kind of sounds very simple concept, but is that simple? So if we look inside one node and see, like, try to decide what actually takes, what it takes to do that. And so let's say we have a microservice. It's both a server, it serves some inbound requests, and it's also a client for some downstream calls, right? And so, and we have this instrumentation in purple, I guess, not purple. I can't tell you this. So instrumentation takes care of extracting your context, your metadata from the inbound request, maybe from HTTP headers like a trace ID, and encoding it into some object in memory. And then by the time you make a downstream call on the client side, instrumentation again takes over and says, okay, that context object, I'm going to encode it again into the outgoing requests, HTTP headers maybe again, right? So again, it still sounds simple, like how hard it is, right? Just put some filters on the server and client things. But the difficult part here is the dotted line between the context boxes, because in order for especially for the instrumentation on the right to be able to encode the context, it needs to have access to that context. And well, that's where the difficulty is, because how do you pass it through? So this is a problem of specifically in-process context propagation, ironically. Like, distributed tracing is all about inter-process communications, but the biggest challenge in instrumentation is in-process. And it's not all bad. Like, if we take some languages which support thread locals, then you can do that actually there. You can just stick that context object into thread local, and it's available everywhere. So it's not so bad. So it's kind of a happy story. But, oh, my picture didn't show, fine. Happy story, but you have still an issue with thread pools and futures and asynchronous communications. They will actually break that, even that simple solution, because, well, thread locals are only good if you stay on one thread, and that's not what modern systems do, right? However, we have another set of programming languages, like Golang and Node specifically, where thread local storage doesn't exist. In Node, there is like a continuation local storage, but not a lot of people using it. It's like considered expensive for performance reasons. And Go has nothing at all. Like, you can't even identify a Go routine in Go. It's a decision by the language specifically. And so what you have to do is you have to pass the context object explicitly throughout your application. So imagine, like, actually, if you go to Go language blog, they have a standard library and standard object called context. And if you read the blog about that, it says you should really pass it as a first argument to every function in your application. Let's not debate how good or bad that decision by the language is, but it's pretty hard in terms of, like, if you've written your application without doing that, then changing it isn't cheap, right? You have to do some work. And therefore, it's not such a funny story here. So in-process propagation is definitely one of the biggest challenges. But another one is also, well, we said that instrumentation for the frameworks is kind of easy, put the filters. But I come from Uber. Uber is a snowflake. So we have 4 programming languages that I showed before. But we also have, like, every team essentially wants to, whatever they want to use as a framework, they use it. Right? So every language has dozens of different frameworks doing similar things, like whether it's HTTP or database access. And me, as a tracing person, like on a tracing team, I kind of have to go and instrument every single one of those so that regular developers don't have to. Otherwise, I just can't like scale this thing, right? So I need to instrument all my infrastructure libraries. So that's very expensive. And that's actually where open tracing comes in, because open tracing is an open source standard for instrumentation. It gives you APIs across different languages, like 6 or 7 at this point. And the idea really there is that, so we've heard probably for some of the vendors that they do like monkey patching, the implicit instrumentation with agents, which is great, like if you don't want to touch the code, but it just doesn't always work. And it's actually very expensive to the vendors themselves, because like if I write a new RPC tomorrow and it becomes popular, then every vendor has to go and write some sort of monkey patching for my RPC with my API. And then in my version 2, I break them because I changed my API, right? So whereas when I'm writing my RPC framework, I say, okay, well, I want to support tracing because I'm like a 2017 developer. I know that tracing is important in distributed architecture. So I can instrument my framework myself. It's not going to take me a lot of time. I just need an API. And until open tracing, there wasn't such API to use. Now there is. So the hope is that open tracing will kind of help people instrument their frameworks. Or if not the owners of the frameworks, at least you can write a plugin for the framework. You have to do it once, and then everybody can use it, rather than everybody re-implementing that stuff. But open tracing still doesn't help with the in-process propagation. It still must be done manually, and specifically at Uber, we have between 2,000 and 3,000 microservices. And the reason I'm giving this kind of vague number is not because it's a secret, I just don't know anymore. Like, we used to track it, whatever. At some point, we had more services than engineers, so we had to hire our way out of it. And on top of that, I have 5 people on the tracing team. So obviously, we cannot go and change, like I said, if it's a Go service, so a quarter of those services will be in Go. I cannot go and change all the Go services to pass the context around, right? So it just doesn't scale. So developers must instrument their own code. What do developers tell me when we ask them to do that? Like, how do we mobilize the organization to actually go and do that instrumentation? That's actually a very hard problem. I call it a traveling salesman problem, 2017 edition, because I am a salesman. I'm building a service, a tool for them to use. So they are my customers. I have to convince them they have to use that, or like they want to use them. That's why I sell them. While as a traveling, well, it's really an optimization problem. How do I optimize my resources on my team to give the biggest impact by doing whatever work we're doing for the whole org and make it easy for everyone? All right. And after doing this for 1.5 years, I think that problem is also NP hard. But kind of the main conclusion is, like, if you want to roll out tracing in a large organization, you have to make them want to use tracing, right? And it sounds like from that demo and from the reaction that it's like, well, why wouldn't everyone? But we here are the monitoring crowd, and that not all developers have that mentality, right? A lot of developers want to I just want to ship my features and bite me, like with your instrumentation and monitoring. I don't want to do that. So to that, we have another approach, which is sticks and carrots, right? So, and I'll talk about that in a second. But so, as a recap, so these are the features that I mentioned. Sticks and carrots, we all know what it is. Like, we need to give them something, or we need to like make it expensive for them not to do certain things, right? So, what can we give them to actually make them interested in instrumenting these things? And ironically, tracing initially started as this kind of, oh, this is an awesome tool for investigating latency performance problems. This is not what been the most frequently asked use case at Uber at all. The use case was service dependency analysis. People just saying, okay, we just built this 2000 microservice architecture. Could you please explain to us what the hell we just built and how it works? No one knows. So SREs, like we have, there's a talk from Lyft about the diagram where there are no services names, but there's like, it was talking about trip flow, right? The core services that critical for trip service, for trip flow. We have the same thing. And SREs in our organization actually introduced a notion of service tiers. So we say like every service which is critical for the fundamental business of Uber to taking trips, right, is like a tier 1 service, and it has additional restrictions on top of it. Like you cannot roll it out globally, you have to do stage rollouts and all kinds of like gates and checks and balances to make sure that there is stability in the system when these services change. Because, well, I don't know if you know that number, but 80% I think of all the outages are due to changes in the system rather than like something happen, you know, nodes go down. So these are basically the main thing that people are looking for tracing. And with the service tiers, we actually had a project where we picked a bunch of high-level entry points into our system, which were responsible for, we knew they were responsible for the core trip flows. And we said, okay, well, what if we just trace those requests through the architecture and see every service that comes up in those traces is, if not critical, then at least it's somehow related to the core trip flows, right? It could be cached, so it's like there may be soft dependencies, and there are ways of dealing with that, like automatically figuring that out too. But that was a very like a strong and useful project, and we've like now we have like a 5-tier hierarchy at Uber, which is in part based on tracing data that we collect. And the last one is the workflow analysis. Here, that's actually what I refer to saying that the dependency diagram that I showed is the most primitive form of dependency diagram you can build with tracing data, right? Workflow analysis is really, well, this core trip flow was actually an example of flow analysis because we've looked at what it takes, what kind of graph we get by executing one single flow. And we can study that. We can like calculate how much traffic goes through each flow. So if you're a service owner and you see 50% of the traffic comes from here and from here, there's little you can do to actually attribute that traffic to any particular business use case because, well, maybe you are a storage service and all the context you get in the request is they tell you, give me the customer ID, right? So like that's it. You can't attribute it to any kind of business functionality. But with tracing, you can. You can just trace it back and say, okay, well, this was actually payment, important for the business, or this was, I don't know, some whatever, some feature which isn't that important, right? But it takes 60% of your traffic, so you can badge it and maybe tell them to put a cache or something rather than hitting you all the time. And the second interesting, like most useful use case for tracing turns out in Uber was baggage propagation or distributed context. So baggage is that metadata that we propagate, and that metadata doesn't have to do anything with tracing. It's just the fact that you propagate in the metadata, which is a key value store, essentially arbitrary. But it's a very powerful technique, and in fact, like it doesn't have to even exist with tracing. You can build that without tracing. And a lot of companies, like if you look at what their services are doing, they actually often build that manually with like, oh, I'm going to propagate this particular HTTP header manually. Why is it bad? Because, well, when next day when you want a new header propagated, then your service somewhere in the middle of the stack doesn't know about it and it doesn't propagate it. Whereas baggage is fundamentally designed such way that services don't need to know. They just propagate blindly unless someone actually reads that data. And so we're using that for two primary purposes. One is the tenancy. So the request comes in, maybe we check, well, it's a test account, or maybe it's like a, what's it called? Not chaos monkey, but well, essentially a performance test, right? We like flood the system with a lot of requests, but we mark them as test requests with a test account. So edge service can check that, and it sets that tenancy. And then as the requests go down all the way to the storage then at the very last point says, oh, you know what? I'm not going to point you to the production database. I'm going to fork you to a test database so that you don't mess anything. But everything else in the stack doesn't even look at it because they don't care. They want to exercise normal business functionality. And the similar thing with authentication tokens. Like you stick it somewhere at the top of the graph. It's available at every node in the rest of the graph. So why am I actually talking about this? It's not exactly tracing. it's kind of back to sticks and carrots, right? So these two teams that do the tenancy and authentication, they are not tracing team. They're teams that build functionality on top of tracing. And that's kind of the very powerful tool in the organization. If you get people to build features on top of what you're providing, then you essentially increase the number of carrots, because there are some other things that developers may want to use, and in order to use them, they have to integrate with your tracing system. And sometimes they can become sticks, because well, tracing and context propagation only works when it works everywhere. Like if there's a break in the middle of your graph, then people will start yelling at you, why haven't you propagated the context? We can't see what's going on in the storage, right? So as a summary, each organization is different. You have to find your ways. You have to solve the traveling salesman problem for if you want to roll it out. Of course, if you're a Java shop, you're done. I mean, you just like drop an agent, or it's very simple to do in a language which support kind of thread local storage. Like in Python, our story for Python at Uber was extremely simple. It's like a config line change, and boom, your service is instrumented for tracing fully, like propagation and all. But with other languages, it's harder. And the final thing, I have, I think, 4 minutes. I want to say, like, if you rolling out this kind of feature across the organization, it's a monitoring feature, you have to measure it, right? And so how do we measure adoption? We originally started with a very simple approach, saying like, so tracing means that not only you propagating the context, but you're also collecting the tracing data, like the tracing spans, and sending them out of the process. So when we see a service doing that, we can say, check, service is instrumented. So that's what we had as the first approach. And there's some daily aggregation job which compares the list of services from some registry with what the data we're getting, and says, okay, these services are not sending us any data, they are not instrumented, let's open up a ticket for them. Especially if they are like a higher tier service, then it may be even a requirement from SREs to implement tracing. And definitely show them a dashboard where people can go and check what's going on. So we started with that. We moved away from that because that kind of measuring, because the problem with that is like it's a pass-fail and it's very easy to pass. So imagine that back to that picture of the server and the client thing, the application, right? So if you instrument your server endpoint and you send spans and traces out of it, technically, by this criteria, you already integrated with tracing. But you may not be propagating context in process, which is the hard part. You may not be sending the traces, like continuing the traces to all the downstream calls. So really, you're not acting as a good citizen in a tracing, but you still got a pass in this criteria. So we switched to another thing, which we actually run another kind of aggregation jobs, and we calculate tracing scores according to a number of criteria. So for example, we see that like a service got called from some service X, and the service that got called is actually instrumented, so it emitted some data tracing, and we say, oh yeah, we saw the call from A or from X. But X never sent us anything, but we know that there is a break, right? And so X may have been actually instrumented as a server itself, but it doesn't work as a client, as a tracing client correctly, right? So we can detect that in the traces by examining them. You can also join with some other data, like we have our routing layer similar to Envoy, and we also used to use like HA proxy. We're migrating away from it, so we can get like some logs from there and basically say, okay, we see communication between these two services, but this particular communication is not showing up anywhere in the traces. So it's like a red mark against that service, and so we collect these metrics and we book tickets for people, for owners of those systems, and we also provide them like detailed reports like this one here. This is some service I just pulled randomly. You see all these criteria. Doesn't really matter what they are. You can actually define depending on your business case, because some of them matter to some people and not all. But we count how many traces we've seen, how many of them pass this particular criteria, and if not, we open a ticket and say, please fix that. And like sometimes the fix is as simple as just let's upgrade the tracing client. But in other cases, it's the instrumentation that needs to be fixed. So that's all I have. This is the summary. So the URL for Jaeger, if you want to try it out, this hot rod demo is all available. You can run it with like a Docker command, very easy. On the same page, if you read the README on that repository, there are links to 2 blogs. One is how we evolved distributed tracing at Uber. It's an Uber engineering blog. article. And another one is if you actually want to do like the hot rod demo, try it out. There's a very detailed walkthrough how you can try it. It's like what things you can see. And it really just demonstrates all the features of open tracing that you can experience with open tracing and with Jaeger as a kind of an implementation of open tracing. And open tracing itself, like open tracing website is opentracing.io. So that's all I have. Thank you very much. I think I have time, right?